Okay, well, what I wound up doing was I'm going to start with the Unit 2. I'm guessing that's probably where everyone would probably be at this point. If you have any questions about anything with the unit before, just let me know, and I can see if I can walk through any specific requests. But let's talk about the decimals and how kids are expected and taught how to add and subtract decimals and all of that fun stuff. Now, remember back in the day when we were kids, I'm just going to use this example here, 0.32 plus 0.17, and we knew enough because we were told over and over again, you add it like you normally do, so 9, 4, and then you put in the decimal point because you have to line it up. Again, rote memory stuff just from procedures of what we had to do when we were kids, and it stuck with me. Does it make much sense to me when it was taught this way? Not really. I just followed what we were told to do. Now the kids these days are taught using a 100th grid. Now you can go out onto the interwebs and you can print a blank 100 number chart, get it laminated, and if you wanted to. Just for now, because I don't have a laminator, I'm going to use the existing information that's in the book. So basically when you're looking at this, and I hope I'm not out of focus, these are 100 blocks that are in here. And let me make sure, 3, 4, 5, 6, 7, 8, 9, 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So there's 100 little blocks in here. And what they have the kids doing is, if you have the question here, you have 32. The kids will be shading in 32 of these. Then with another color, they would be using these and shading in this color. And then the answer would be adding all of the shaded colors up. And that's the easiest way for them to do it. The same thing with subtraction is they're going to shade in all of the larger number, the 61, and then they're going to cross out the 42 with little x's, and then they count what's left over. Okay, a good way that I like to think of how to express decimals in a real-world situation is definitely the use of money. I have to say it's probably one of the most important things that have come out of the use of decimals and teaching decimals and using it in the real world. Some of the other things, not so much, but definitely when it comes to money, it's a decimal-based system. And when it comes to trying to determine which amount, like for instance, which is greater, let's do 0.32 versus 0.24. I know there's examples in there where they want you to, which is greater than, less than, equal to. Good way to explain it is it's money. 32 is the same thing as 32 cents. 24 is the same thing as 24 cents. Which is more, 32 cents or 24 cents? 32. Now when it comes to the boxes and using the 100th grid, and I have one over here too, think of this as $1. And each little box is a penny. So what you're doing is you're going to be basically doing 52 cents minus 41 cents. At least it gives a good real world use that the kids can relate to. And it's a lot easier to explain as an adult too, because it's something that we use all the time. So again, this is the same thing as $1. All of these, because they're decimals, fractions, seem to, if you remember back from our days in school, this whole thing, it's a whole. So this is one whole, and these are parts of the whole, and when you put them all together you get one. Or as we're going to be adding more, and you'll be getting ones, twos, threes, but you'll be getting whole numbers. So again, money. This is $1. These are pennies. And you're going to ask them to do, okay, I want to know what 22 cents plus 35 cents is. Have them shade in, they already have it shaded for us, shade in everything, and then you add it up all together. And if you wanted to, for extra fun, you can say, well, how much more money do you need to make $1? So the 22 is the light gray, the 35 cents is the dark gray, the white is what you would need to make $1. Okay.